In this video, we'll learn about quarks, a type of fundamental particle. We'll learn about the properties of quarks and how they can combine to create larger particles like the proton and neutron. This is an atom of helium. Its nucleus contains 2 protons and 2 neutrons. Surrounding the nucleus are the 2 electrons in the electron cloud. Now, which of these 3 types of particle are fundamental or elementary particles? Fundamental or elementary particles are particles that are not made of smaller particles. You might have thought that the proton, neutron, and electron are all fundamental particles. While that's true for the electron, the neutron and proton are not. If we could zoom in on these 3 particles and take a look at them somehow, we would see that the proton and neutron are each made of 3 smaller particles. These smaller fundamental particles that make up the proton and neutron are called quarks. As we can see from this diagram, there are different kinds of quarks. The different kinds of quarks are called flavors, and yes, that's the scientific term. There are 6 flavors of quarks: up, down, charm, strange, top, and bottom. Quarks, together with the other fundamental particles, make up what's called the Standard Model. The Standard Model is made of some particles that are familiar to us, like the quarks, the electron, and the photon, as well as many other particles that we probably haven't seen before. These particles on the left in the Standard Model are called fermions. Fermions are the building blocks of matter, just like the quark and the electron that make up atoms. These particles on the right in the Standard Model are bosons. Bosons are responsible for the fundamental forces of nature. Photons, for example, are emitted or absorbed whenever there's a change in electromagnetic radiation. We don't need to worry about the details of the Standard Model because this is getting well into the realm of particle physics. So let's move on to the properties of quarks, starting with the electrical charge. To express the charge of quarks, we'll use elementary charges denoted by the letter E. For reference, the charge on the proton is positive 1e, and the charge of the electron is negative 1e. The electrical charge of quarks depends on their flavor. The up, charm, and top quarks all have a charge of positive 2/3 e, while the down, strange, and bottom quarks have charges of negative 1/3 e. In nature, quarks never exist on their own. Quarks are always found in groups of 2 or 3. Quarks are held together by the strong force. A group of quarks held together by the strong force creates a larger particle. These particles that are made from quarks are collectively known as hadrons. 2 examples of hadrons that we're familiar with are the proton and neutron. Let's see which quarks make up the proton and neutron. The proton is made of 2 up quarks and a down quark. The neutron is made of 1 up quark and 2 down quarks. We can calculate the charge of the proton and neutron using the charges of the quarks that they're made of. The proton is made of 2 up quarks, which each have a charge of positive 2/3 e, and 1 down quark, which has a charge of negative 1/3 e. This gives us a charge of positive 1 for the charge of the proton, which is what we'd expect. If we add up the charges of the up quark and 2 down quarks that make up the neutron, we get 0. Again, what we'd expect for the charge of the neutron. Now we've learned what quarks are, the different flavors of quarks, and the properties of quarks, so let's test our knowledge with a problem. Which of the following is not a type of quark? A, up, B, bottom, C, strange, D, left, or E, down? Quarks are a type of fundamental particle. Quarks combine to make other particles like the proton and neutron. There are 6 types of quarks which are called flavors. The different flavors of quarks are up, down, charm, strange, top, and bottom. This question asks us to identify which answer choice was not a type or flavor of quark. Looking through our answer choices, we'll see that though many of the quarks have directional names, left is not one of them. A composite particle is composed of 2 up quarks and 1 down quark. What is the overall electrical charge of this particle? A quark is a type of fundamental particle. A fundamental particle is a particle that's not made of smaller particles. In nature, quarks never exist on their own. They combine to create other, larger particles. The composite particle in this question is made of 2 up quarks and 1 down quark. The particle that's made of 2 up quarks and a down quark is the proton. The overall electrical charge of the proton is +1. If we didn't identify this composite particle as the proton, we can still answer this question. We can calculate the overall electrical charge of the particle using the charges of the quarks. The up quark has a charge of +2/3, and the down quark has a charge of -1/3. If we add up the charges for the quarks that make up the composite particle, we get +1. So either way we solve this question, the overall electrical charge of the composite particle is +1. Now let's sum up this video with the key points. Quarks are a type of fundamental particle that makes up protons and neutrons. There are 6 types of quarks, which are called flavors. The 6 flavors of quarks are up, down, charm, strange, top, and bottom. The up, charm, and top quarks have a charge of +2/3 E, and the down, strange, and bottom quarks have a charge of -1/3 E. Protons are made of 2 up quarks and 1 down quark, while neutrons are made of 1 up quark and 2 down quarks.